Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is Physical and Chemical Modification question banks. In this, what kind of questions they are asking, how we are going to analyze such type of questions, and what kind of things we are going to do in as per this module. So in this module, we are going to describe the process and application of soil stabilizing using lime. So this is first what we discussed. This is the one of the one kind of question. So in this, using lime, using cement, using any other kind of, they may ask. So according to this, we are understanding the process and applications of soil stabilization using lime. What are the chemical reactions which are involved? How do they improve the soil properties? It may ask cement in place of lime, any other kind of chemical they may ask. So before going to the lime stabilization particularity, so any kind of material, any kind of chemical, we may understand this question. So process of lime stabilization. So the first step is the site preparation, and the next one is lime application, mixing, moisture addition, compaction, curing. These are the steps which we are going to involve any kind, not any kind, but they are each kind of chemical stabilization represents their own kind of steps, but the process is same. So the site preparation, application of that chemical reaction, mixing, and what is the addition is required for that particular chemical reaction, and any kind of particular property. So it is depends upon. So not exactly this terminology, but this kind of process for any kind of chemical stabilization. So in this lime stabilization, these are the particular steps which we follow. So that is site preparation. First, we are going to prepare the site. The soil surface is prepared by clearing without any vegetation. So we clear the ground. So like that, we have to understand this chemical stabilization. So the soil surface, whenever we are applying this chemical, so there the site should be prepared. So after that, we are applying the lime. So in this lime, quick lime or hydrated lime is spread uniformly over the soil surface. So any kind of chemical, it depends upon the nature of that particular chemical, we are applying uniformly over the soil surface. Now in this lime, the lime is mixed thoroughly with the soil using mechanical equipment such as rotary mixers. So using those kind of rotary mixer, using mechanical equipment. So based on that, so we are mixing this chemical, what kind, whether it is lime, whether it is cement, so thoroughly with the soil using the mechanical equipment. These kind of terminology or words which we are used, those are relevant to that particular chemical. So for lime or any other chemical, the mixing of soil using this mechanical equipment. So using these technical words which are relevant to that particular question, so that is most important in examination. So the lime is mixed thoroughly with the soil using mechanical equipment such as rotary mixers. So in this moisture addition, water is added to initiate the chemical reactions and ensure adequate compaction. So here the chemical reactions and ensure adequate compaction, we have to moisture addition is required in this as a process of lime stabilization. So in this, the compaction, the soil lime mixture is compacted to the desired density using rollers. So the soil lime mixture is compacted desired density using the rollers. So it may different for different types of chemicals. So we have to write those kind of terminology for whatever the chemical stabilization which is their relevant terminology we may use. For this lime, the soil mixture is compacted to desired density using the rollers. Here the compaction is the property. In some other chemical it may different. So whatever it may be, what is the process we are following for that chemical as per the desired modification of the soil. So and the next one is curing. The stabilized soil is left to cure, allowing the chemical reactions to complete the soil to gain the strength. So here they are asking about the chemical reactions. We may use whatever the equations we will get. So we may use those overall chemical reactions if you want. So here where we are applying these chemicals reaction. So these chemical stabilization where we are using is also the one of the important parameter. So in this pavement construction, foundations, soil stabilization, landfills. So each kind of chemical stabilization have their own applications. So in this especially for lime stabilization we are talking about the lime stabilization here. In lime stabilization is used to pavement at the time of pavement construction to improve subgrade and base layers in road construction. So as a part of road construction, whenever we require the improved subgrade and base layers, we are using this kind of lime stabilization. And in foundation, enhancing the load bearing capacity of the soil for building foundations also, we may choose this kind of chemical modification. Whenever we are require this chemical modification, we may choose this type of lime stabilization for load bearing capacity enhancing in building foundations. And the next one is slope stabilization, reducing the erosion and improving the stability of the slopes. In that particular conditions also we may choose this kind of ground improvement technique, that is lime stabilization, ground modification technique, that is lime stabilization. And landfills, so stabilizing the waste materials and preventing landslides, whatever such kind, we may choose these kind of stabilization also landfills. These are the some of the applications which we choose for this lime stabilization. For lime stabilization, these are the some of the application. In this, they asked the chemical reactions involved. It may ask, may not be asked, it depends upon the question. If they ask, we may write about the how it reacts, and you may choose the equations also. If you are comfortable, write about the equations if you are confident. So in this chemical reaction, cation exchange, pozzolanic reactions are happened. This is enough. How? What are the chemical reactions involved? They are asking. So these are the chemical reactions which are going to involve. If you want to enlarge and if you want to write the chemical reactions, it depends. Why? Because I am not mentioning is it because each kind of soil has their own kind of the organic matter. So the percentage it may vary. So we can't tell one thing without getting any kind of special particular area region. Whenever we are talking about, then only we are going to write about those equations. Otherwise, it may different. So based on that soil conditions, how much these lime we are using, these are all the how much chemical we are using. So according to that chemical, how the reactions are there. So based on the organic matter and soil nutrients which are present in that particular region, soil is the major parameter for this chemical reaction. So here according to the question, what are the chemical reactions involved? So for that only I mentioned this cation exchange, pozzolanic reactions. So particular whenever you are using, whenever we done after completion of lab test for particular soil, we may mention these equations also. So in these chemical reactions, cation exchange, so calcium ions from the lime replace the cations adsorbed on the clay particles, leading to the fluctuation and aggregation. So this is the chemical reaction which is happened for lime stabilization. So the equations which are depend upon the soil properties as well as the lime properties. And the next one is pozzolanic reactions. Silica and alumina in the soil. So how much they are involved in the percentages, it depends upon the soil sample where we are going to construct that particular. So each kind of soil has their own kind of percentage of silica and alumina. So each and everywhere same kind of it's not there. So like that, that's why I didn't mention. So in this silica and alumina is the soil react with lime to form calcium silicate. So calcium silicate hydrate CSH and calcium aluminium hydrate CaH, which are cementitious compounds. So we know the cementitious compounds are going to pozzolanic reactions. So these are the two chemical reactions which are going to happen in our lime stabilization. So every different kind of chemicals has their own kind of reactions, chemical reactions based on the type of the soil. How much organic matter which are going to there in that particular soil. So according to that, we are going to understand the chemical reactions. So improved soil properties. What kind of soil properties are going to improve or modified because of this lime? Modified because of this soil, because of this lime stabilization. Those are increased strength, it reduces the plasticity, improved workability and enhanced the durability. These are the some of the modifications which are happened in our soil properties. So in this increased strength, formation of cementitious compounds increased the soil's compressive and shear strength. So based on the compressive and shear strength, these are going to increase by using this lime stabilization. In lime stabilization, this is the one of the modification which we get in our soil. So that increased strength gives, it is helpful for any kind of construction work. Now reduced plasticity. The soil's plasticity index decreases, making it less susceptible to volume changes due to the moisture variation. So in this reduced plasticity, so the making it less susceptible to volume changes due to the moisture variation. So the reduced plasticity. The next one is improved workability. So the fluctuations of clay particles improve soil workability and reduces the stickiness. And also the lime stabilization techniques helpful for the enhanced the durability. So lime treated soil have increased resistance to frost and chemical attack. So these are the improved or modified soil properties which we get by these using this lime stabilization. So these are the things which we discuss. So how the improvement and also what are the chemical reactions, where we are applied and what is the process. So any kind of chemical stabilization we may analysis like this. And move on to the next type, that is explain the process of cement stabilization. So we see the lime stabilization. So in this we observe. So then we will get the how we write the process. So what are the benefits and potential limitations of using the cement for soil stabilization? This is the question. Now process of cement stabilization. Whatever it may be the stabilization technique. The first one is site preparation. Any kind of ground improvement technique which we choose, most of the cases site preparation is the one of the primary steps which we do. So in this site preparation, the area to be stabilized is cleared and leveled. So the area stabilized, cleared and leveled. And next one is cement application. In previous, according to the lime we are talking, now here move on to the cement. So here cement application, Portland cement is uniformly spread over the soil structures. So once we are spreading the soil structure. Now the mixing. The cement is thoroughly mixed with soil using the mechanical mixtures. And moisture is addition. Water is added to initiate the hydration process. And the next step is compaction. The soil cement moisture is compacted to the desired density. Then curing. The stabilized soil is left to cure. along the cement to hydrate fully and gain strength. This is the process we may write in enhanced point of view also as per the marks which are allotted to that particular question. So what are the benefits which are going to involved in this chemical stabilization? Increased strength, improved durability, reduced permeability, enhanced load bearing capacity. These are the some of the advantages which we are involved in this cement stabilization technique. So using cement stabilization significantly increases the compressive and tensile strength of the soil. So cement treated soils have better resistance to weathering, erosion and chemical attack. It leads to improve the durability of the soil. In reduced permeability, because of this, the formation of cementitious bonds reduce soil permeability, preventing water from infiltration and improving stability. So it leads to the reduce the permeability and enhance load bearing capacity. So stabilized soils can support heavier loads. So because of the cement stabilization, it is strengthen the soil to support the heavier loads, making them suitable for foundations and pavement structures are also. These are the benefit which we observe in our cement stabilization. So in these also limitations are there in this cement stabilization technique. Those are cost, environmental impact based on the soil type, curing time. These are the some of the limitations which we observe in this cement stabilization technique, because it can be expensive, especially for large scale projects. It is more expensive because of the cost. And also the production of cement generates CO2 emissions, contributing to environmental pollution. So it leads to the environmental impact also because of this type of technique. And one more, this soil type depends upon the soil type. The effectiveness of cement stabilization varies. It depends upon the soil types. It is highly organic soils or soil with high sulfate content may require additional treatment. In curing time, the soil cement mixture requires adequate curing time to achieve the full strength, which may delay the construction activities. These are the some of the limitations which we observe in our cement stabilization. So now discuss the principle and applications of chemical grouting in soil stabilization. What are the different types of chemical grouts? How do they improve soil properties? So this is also another kind. Here the involvement of chemical grouting principles and their applications. What are the types, different types which are involved for these chemical grouts? Which type of soil properties it is going to modify? So in this, the first one is principles of chemical grouting. So chemical grouting involves injecting chemical solutions into the soil to fill voids, bind soil particles and increase soil strength. So the grout sets and hardens within the soil, forming a solidified mass. In these applications, foundation stabilization, leakage control, void filling, erosion control, these are the major applications which we are involved in this chemical grouting. So in this foundation stabilization, improving the bearing capacity of the soil under foundations. Leakage control, sealing leaks in tunnels, dams and underground structures. And also void filling, filling voids and cavities in soil and rock formation. This is also one of the application which we choose for this chemical grouting technique. Erosion control, it prevents the soil erosion and stabilizing slopes. These are the some of the applications which we choose for the ground chemical grout technique. So in these different types are there. Those are sodium silicate grout, polystyrene grout, acrylate grout, epoxy grouts. Various types are involved in that. Every type composition, application properties are there for each and every type of the grouts. In this sodium silicate solutions mixed with hardeners. So these kind of grout we used for sealing leaks, stabilizing the sandy soils. So it depends upon the we choosing these type of chemical grouts based on the type of soil, and this properties forms a gel-like substance that bends soil particles. That binds the soil particles. The next one is here, the composition is two component system consisting of a resin and a hardener. Resin and hardener. These kind of grout we use for waterproofing and sealing cracks in construction structures. So in these properties, so what it will do, expands upon injection, filling voids and forming a waterproof. So choosing of the chemical grout depends upon the, it depends, choice of type of chemical grout. It depends on type of soil and required modification. So because expands upon injection, filling of voids, forming a waterproof barrier is the properties which we get by using this kind of chemical grout technique. Now the next one is the composition, acrylic polymers mixed with initiators and catalysts. So in this used for soil stabilization and sealing fine cracks. These properties are low viscosity. Whenever we require the low viscosity allows for deep penetration into the fine soils. And epoxy grouts, this composition epoxy resins mixed with curing agents. So we are mixing these kind of grouts at the time of curing. So these are going to apply used for structural repairs and anchoring. So whenever the properties of these kind of grout is high strength and addition of two variety of substrates. These are the various types of the grout, chemical grout. We choose which type of grout for the enhancing or modification of the soil properties based on the type of the soil and required modification. So here improvement of soil properties using these chemical grouts, those are increased strength, reduced permeability, enhanced durability and stabilization of loose soils. In these chemical grounds bind soil particles, increasing the soil's compressive and shear strength. So the grout fills voids and reduces soil permeability, preventing water infiltration and enhancing stability. So in this enhanced durability, grouted soils have improved resistance to chemical attack, erosion and weathering. So the stabilization of loose soils, chemical grouting can stabilize loose and granular soils, making them suitable for construction. These are the some of the modifications which we observe using this type of chemical grouting. And another kind, explain the process and benefits of using geosynthetics in soil stabilization. What type of geosynthetics are commonly used? What are their specific application? The process of using geosynthetics, those are site preparation, clearing and leveling the site where geosynthetics will be installed. The next one is placement of geosynthetics. So geosynthetics such as geotextiles, geomembranes or geogrids are placed over the prepared soil surface. And the next one is anchoring. The edges of geosynthetics are anchored to prevent movement during the installation and use. Covering and compaction. The geosynthetics are covered with soil or aggregate and compacted to ensure stability and proper function. These are the processes which are involved in geosynthetics. So the site preparation is the common, and the later the next steps are going to change as per the technique we are going to understand. Here the placement of geosynthetics and anchoring, covering and compaction are the process which are involved in this geosynthetics as a soil stabilization. In this various types are involved. Those are geotextiles, geomembers, geogrids, geocells, geonets. These are the various types which are involved in this geosynthetics soil stabilization process. So what are the types are commonly used? So in this, where we are, it depends upon the choice of this, because based on the application and the type. So based on that, we are going to choose the type of the geosynthetics. So in this, used whenever you are geotics, we are apply used for separation, filtration, drainage and reinforcement. So in this, woven, non-woven and geotextiles. So these benefits prevent soil mixing, improve drainage and enhance the soil property are the benefits of these type of geotextiles. And geomembranes, these are going to use it for containment on the lining of the ponds, landfills and reservoirs. These are, and different types are there. HDPE, LDPE, PVC and EBDM geomembranes are available. These are the various types. Because of choose these type of geomembranes, we are going to improve the provide an impermeable barrier, preventing fluid migration and contamination. These are the benefits which we get by using these geomembranes. In GeoGrid, we are going to apply, use it for soil reinforcement, slope stabilization and retaining wall construction. In uniaxial, which types? Biaxial and triaxial geogrids types are available in as a part of geosynthetics. So benefits are improve soil stability, distribute loads and reduce settlements. Geocells are going to apply, used for slope protection, erosion control and load support. These kinds of types we are used for cellular confinement system, and also we are getting the benefited by enhance the load distribution, prevent erosion and stabilize slope. These are the things which we observe in the geocells types. And the geonets we are going to apply, used for drainage and liquid collection. So these kinds are biplanar and triplanar geonets are available. Those are the two types. So provide efficient drainage path, reduce hydrostatic pressure and enhance soil stability are the benefits for these geonets. So according to the various types, we are going to apply in different soil scenarios, required scenarios are getting the desired properties. So in these also each has different type again. Geotextile have their own different types, geomembranes are their different types, geogrids also available in different types, geocells are also available and in different systems as well, geonets. So according to their different types, we are going to choose as per the applications, and finally what type of benefit we required or what kind of modification is required is the parameter for choosing the type of the geosynthetics. So using these geosynthetics, we are getting these enhanced strength and stability is the benefited, and improved drainage and filtration, erosion control, containment and barrier, cost effective environmental benefits are the some of the benefits which we observe choosing these type of improvement technique. So in geosynthetics, reinforced soil increasing its load bearing capacity and stability. So in geotextiles and geonets, improve drainage, preventing the water accumulation and reducing the pore pressure. Using geocells and geotextiles, prevent soil erosion and protect slopes from the environmental degradation. So same kind of benefits we may get, but choose of the which type is suitable is depends upon the soil parameters. So according to that, we are choose the method. And containment and barriers, geomembranes provide an effective barrier for containments liquid and preventing contamination. Cost effective, geosynthetics reduce the need for traditional construction materials, lowering overall project cost. And also geosynthetics are environmental friendly, reducing the carbon footprint of the construction projects. These are the major benefits which you observe for using these geosynthetics. So these are the some sort of questions may ask in our module 4. So we have to understand, and we are as per the based on the question we are going to understand the things. So This is the end of the module 4. We will see with module 5 in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.